So these are polygons. These are not polygons. Who can tell me what makes a polygon a polygon? What makes a polygon there, Isaac?
Is it lines that come together without like having like extra pieces like left over?
Yeah, kind of more or less. It's a, go ahead, Pravi.
A polygon is a closed figure with no curves and no open lines.
Yeah, so basically, a polygon, here we'll just make it big. Okay? Make it big. Watch this. A polygon is, what is not a polygon? A polygon is a closed figure in a plane. If you don't write it down, don't worry too much about it, okay? It's a lot of words to write down. A polygon is a closed figure in a plane formed by connecting line segments endpoint to endpoint. So that's why these are not, that's why that's not a polygon. With each segment intersecting exactly two others, okay? So each segment has to connect to others. Each line segment is called a side of the polygon, and each endpoint where the sides meet is called a vertex of a polygon. So that's kind of all you have to know. So polygon is a closed figure in a plane formed by connecting line segments. So that's why this could not be a polygon because it's got a curve. This could not be a polygon because it intersects more than it intersects in the middle, okay? And each endpoint where the sides meet is called a vertex, right? So that's what a polygon is, and then we're going to talk about some terms with polygons. Ready? Is that enough to look at that? Do you want to write it down? You don't have to. Okay. So next page. So let me draw a picture of a polygon. This is my favorite tool. I can draw a picture of a polygon. Boom, 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 boom. Let's see what that does. Oh, isn't that cool? Have I shown you this tool before? Yes. Okay. So when I label a polygon, I label it by its vertices. A, B, C, D, E. Okay. So A, B, C, D, those are all vertices, right? Vertices, A, B, C, D, and E. And then sides, you know the sides, like side A, B, etc. Okay, up, 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 up. Consecutive sides, you guys know what they're talking about when they talk about consecutive sides. What's consecutive mean? In a row, okay? So A, B, and C, D. No, it's not. A, B, and C, D are not consecutive sides. A, B, and what?
BC.
BC are consecutive sides. And then BC and what? CD and so on and so forth. So those are consecutive sides. Then we're going to talk about some of the names of polygons. So a polygon with three sides is called a
Triangle.
triangle. Okay? Four sides? I'll give you a hint. Quadrilateral. That's why you can go and hang out in the quad, because it has four sides. Okay? Oh, I didn't tell my best joke. Quadrilateral. Is that how I spell it? Quadrilateral? Yeah. So this means four. This means sides, right? Quadrilateral. And now the quattro has what? Four-wheel drive, right? That's like quadritraction. Jeep has quadritraction, baby. What's a pentagon?
5 sides.
5 sides. So pentagon. Pentagon is 5. Hexagon is 6. You guys know all this, right? You guys know what a 7?
Separate heptagon.
I think they call it a heptagon. Heptagon. 8. You guys know? What's 8? Stop sign. About to sneeze. Excuse me. 8 is called an octagon. stop signs or octagons. Okay. Octagon, and I think after that, 9 we don't worry about. 10 they call a decagon, and the 11 after that they just call it like 11. They call it a 11 gun.
Isn't 12 dodecagon?
Yeah. They just call this an 11 gun. 11 gun. Yeah, 12 is a dodecagon. 12 dodecagon. If you have a test or something, dodecagon, I would expect you to know the basic ones: quadrilateral, pentagon, hexagon, octagon. After that, I would probably tell you, but you know, what's a heptagon? Did I have heptagon? If they say, oh, draw a heptagon, you can ask me, what's a heptagon again? I'll give you some size. You don't have to memorize everything. But you know what a polygon really is? It's when your parrot doesn't get any lunch, so he leaves. You get that, Elizabeth?
Yeah.
Good, okay. All right, so a decagon is when you're playing cards and you run out. And a dodecagon is when a female deer is playing cards and she runs out. Okay, all right, anyway, shut up, Mr. Leader, these are bad. Okay, so a diagonal of the polygon, which you need to know. Let's see, I'm going to check. That's a circle. That's not a polygon, is it? Okay, so, oh, I have the wrong tool. Here we go, let's try to draw. Let me see if I can draw a hexagon. Oh, so is that a hexagon? 1, 2, 3, 4, 5, 6. So this thing is a diagonal. If I were to draw a line, oh, I don't want the arrow on it. If I were to draw a line from here to here, that's called a diagonal. A, B, C, D, E. I could draw another diagonal from E to C. Okay, who could give me a definition of a diagonal? So I'm going to give you a definition. Peyton's place. No, I can remember you. No. Go ahead.
A diagonal is a line connecting from two vertices.
A line segments connecting.
2 points or 2 vertices.
Very good. Connecting two vertices.
And then would you put it in a polygon?
A polygon. There's something missing. Okay? That's good, but there's one thing missing. What? So with Peyton's definition, this would be a diagonal, right? Right? So you want to revise that, Isaac?
You can't go to the one next to it.
Okay, exactly. So you would say any two non-consecutive, okay? Meaning non-consecutive vertices. Okay, so a side is not a diagonal. Right? We'll get through it. Good? Yes, ma'am.
So does the line have to go through the shape? So if it's like 2 points,
Aha.
can you?
So that's another thing we didn't talk about. If I were to do, I don't want that tool, I want this tool. If I were to do a polygon like this, make it there, okay? That's called a concave polygon. Concave, because it's got a dent in it, okay? This is called convex, okay? With a concave polygon, you can have diagonals that are outside of the polygon. Okay? A very good question. Right? You can also have diagonals that are inside the polygon. But, I mean, that's a diagonal too, right? And that's where we, let's see, can I draw one from here to here? Not really, that one would be kind of classic. So with a concave polygon, some of the diagonals will fall outside. Convex, they all fall inside. Is that your question? Good. Okay. So congruent polygons. Congruent polygons. Sorry about all these definitions, but we'll gotta kind of do them. Congruent polygons. So I'm going to draw a picture of congruent polygons. Let's see if I can do that. Think about it. There's one. I'm going to make a copy of this. Now I'm going to take this polygon and I'm going to do something to it. Whoa. Isn't that cool? Okay, so congruent polygons. What goes with this? Where does this go? There. Here, right? Here?
Yeah.
No.
Mm-hmm.
Yeah, here. Right? And so congruent polygons, all corresponding and this word's important, corresponding sides and angles are congruent. Remember that symbol means congruent? So congruent polygons are all corresponding sides and angles are congruent. So if I call this A, B, C, D, and I call this one, so if I say A, B, C, D is congruent to what's good, G, H, I, J, what would G have to go with? A. So I have to look for the side that corresponds, or the angle that corresponds to angle A. Where's this angle A? Where does G go?
Top right of
Here, right? No.
top right.
Here, right? G. And the way I can tell by these marks, right? This has 3 and 4, and this has 3 and 4. So that has to line up. Okay? Where would H go? Would it go here or would it go here? Where would
Or
H
the
go?
G.
Let's see, this has 4, this has 2, this has 4, this has 2, right? So that would have to go here, right?
Yes.
So G, H, I, J. So when you write congruent polygons, the things need to correspond. So the side that has 3 marks needs to line up with the side that has J marks. So without even looking at the picture, if they give you this congruent statement, say they say side AD, which side is side AD congruent to? J, GJ, just by looking at the statement, not by looking at the picture. See that? Just by looking. So AD, where's AD? AD would have to go with GJ. Do they both have 3 marks on it? Oh, yeah. What would C, angle C, have to go with? Angle C would have to go with angle I. So this angle has to go with that angle. So C and I both would have 1 mark on it. What would angle D have to go? J have to go with? J would have to go with D over here. See? J over here has to go with D over here because they're in the same place in the order. So this tells you these are consecutive angles. These are consecutive angles and they correspond, meaning they line up. So D would have to go with J. So this would have 2 marks on it, okay? And if I put 3 marks on H, which other one over here would have to get 3 marks? B, right? Because it corresponds, and so on. You get that? Okay. So that's corresponding. Last thing, well, a couple of short things. Equiangular, oh, I don't like that paper. Equiangular, what do you think that means? Equiangular polygon. What is it? Anyone want to guess? Other than Isaac? Okay, go ahead. Wait. What's with me? Sorry, Provi.
Would it be all the angles are the same?
All the angles are the same. Can anyone know what an equiangular polygon would look like? What do you think they're? Julia.
A square.
Well, yeah, a square is equilateral, but and equiangular, right? So if I draw a square, is that a square?
No.
That looks more like a rectangle. So if I think it's oh, you know what? My screen is distorted. But if it were a square, then it would be both. But if it's just the side, just the angles are congruent, like in a rectangle, then it's equiangular. Can anyone think of another shape? Sorry, that's equiangular. What do you think there, John?
An equilateral triangle.
An equilateral triangle. Could an equilateral triangle? Do I have one here? That looks kind of. Oh no, that looks like an isosceles. But there you go, right? Equiangular or something like that. But you would have to indicate to show it's equiangular. You have to say that angle is congruent to that angle. That's congruent to that angle. I think this is the only shape. Don't quote me on this, but that's equiangular without being equilateral. You know what I mean? So, which gets to the next thing. Equilateral means what? Where are your lats? Over here, right? On your sides. If you're playing football and you throw it to the side, what's that called?
Lateral.
A lateral, right? So equilateral means equal sides. Okay? Equal sides. Can something be equal sides? Could something be equilateral without being equiangular?
No.
Yes. How about one of these things? Oops, that's my video. No, I don't want that. Oh, I want my shape tool. I think I have some. Oh, here's my shapes. How about this? All the sides appear to be equal?
No.
Well, I think so. I think in that star, all the sides, are all the angles equal?
No.
Probably not. Okay. Anyone think of another shape? I can. What do you call that? Rhombus, right? We'll get to quadrilaterals, but a rhombus can have equal sides. Okay, last one, regular polygon. It's a polygon that is both equiangular and equilateral. So what's a shape that's regular?
A square.
Equal, yeah, that's one. One is a square. So you have a square. You could have a equilateral triangle. Because an equilateral triangle has angles. If this I guess not that star. Are there other one? Yeah. You could have lots of them, like you could have a regular hexagon, right? If I drew it like that, equal sides, equal angles. I could have a regular pentagon, equal sides, equal angles. Yes? Okay, so those are figures that are regular. Equal sides, equal angles, or congruent sides. And Lauren's here to finish her quiz. Here, you can sit down. You could just sit in the back. Is that okay? Where's my start? Oh, nice. Okay, so I think that's all I'm going to teach you. That's enough for today, isn't it? Is that enough?
Yeah.
Yes, please. Okay, so your homework is gonna be page. Oh, I'm giving you too easy an assignment. You'll be done in a minute.
I don't
We don't
think
need an assignment.
no.
Page 56, 1 through 31 odd. I was gonna. Some of you did that midpoint assignment already. I forget what page it was, but it was like 1 through 8. We'll come back to that probably on Wednesday or something, so don't worry about that. On my website, it says also do this stuff on midpoints, but you guys had your fill today, so that's enough. You can start on that, and